howdy, everybody. Welcome to another episode of Ask Paul. Of course, my name is Paul. Welcome to the podcast where we answer those pressing questions that are submitted via the Ask Paul portal over on paulabernathy.com, which again is part of Electrical Code Academy, the corporation based in Texas. And if you're not familiar with Electrical Code Academy, we're the ones that teach you the National Electrical Code. And it's a very comprehensive program, whether it's residential, commercial, industrial, grounding and bonding, or our famous Fast Trax program. We literally have so many students in our Fast Trax program. And if you ask any of our students that actually use the program, that are in it, they'll tell you how deep and embedded that program can be in understanding the National Electrical Code. It gets really deep, really good competency review questions. And again, you can always attend our Wednesday night classes where you can ask me any question on the National Electrical Code and we will examine it. So again, check that out. If you haven't before, just go over and check out electricalcodeacademy.com.net or .org, and you can check it out. All right. So on today's episode of Ask Paul, we don't always get questions that are code related. Sometimes we'll get questions that are just asking us questions. And again, when I'm picking questions, I'm trying to pick questions that I can, answer and be able to articulate well in a podcast format. So the first one that comes up today is really a question about our programs. So again, if you're one of those that are like, okay, all right, Paul's getting ready to run a commercial. Okay, get the conspiracy thing out of the way. Again, it is what it is. We pay the bills. But this question legitimately came in, and it says, "Hey, Paul, love the show and get ready to purchase and start your Fast Trax program. Just wondering how long before testing should one take after starting your program, or how long does the program take to get through the entire program, I should ask." Okay. Good question. For those out there that are interested in exam preparation, I would like to think I'm one of the authorities on that when it comes to how you develop a program, what resources you use, who you partner with when I create a program, and how I take an existing course book and how I enhance it for you to really understand the NEC rather than just watching a bunch of DVDs and rewinding and trying to get it. And then, of course, putting you together with me as your instructor. You become one of my students, and my goal is for you to succeed. So when you start a program like our Fast Trax program, we tell people, we don't want anybody who, and again, some people will, I guess my sales team, Darlene, Brittany, Zach, they'll cringe when I say this, but we're not looking for people that are going the fast, quote, track, less than 60 days. Okay, so we consider Fast Track being at least dedicating 60 days or 90 days into the program. That's what we think about when we're talking about the Fast Track, not the immediate cram course track, okay, where you do something on a weekend. I'm not a believer in that. Most people know that. I don't believe you can retain it, and when you get into a stressful situation, you start trying to remember all these tips and tricks that people will try to teach you, these acronyms or all this stuff, and you end up losing it. And I say this because I have so many students that I work with that this is the feedback I get from people. And this is why they come to me, because they're having this time during a test. They're struggling during an exam. So at the end of the day, I designed this course with that in mind. And so there's a lot of reading, a lot of graphics. Thank goodness. The textbook that we use integrates that very well. Charles does a great job of doing that. And then, of course, we back that up with competency reviews that we personally grade, and we grade on Monday, Wednesdays, and Fridays. And that way it keeps you into the course and up on the course. We don't want you to go too fast because you can lose the little subtleties of the course, and your grades will show that. So students, we track the algorithm of the grade. So when you start to dip down, we can tell, and we'll give you a little message inside of one of our reviews. We'll say you're going too fast, you need to slow down, because you do have access for a year. So, but to answer the question, to adequately finish the course We believe in 90 days. Now, there's people that take 6 months, and that's fine. You go at your own pace. If you're not taking an exam for 6 months to 8 months from now, that's perfect because you can go at your own pace. You don't have to be in a hurry. However, if you're going to study within 60 or 90, if you're going to take a test at 60 days or even 90 days, and again, we recommend 90, but if you're doing it at 60, that's okay. We do give you what's called a study plan. Now, remember something, and I usually have to explain this to people. A study plan is not the Fast Trax program. So people that email me or call me or send something in, they'll say, I want to get in the 60-day program or the 90-day program. There is no such thing. Okay. There's no such thing as a 60 or 90-day program. Okay. It is a Fast Trax program. You have access for 1 full year, 365, 24/7. The study plan is a 60 or 90-day study plan that we created to help keep you on track, right? Keep you focused on your study time because you have a deadline, right? You need to take your exam within 60 days or you're taking an exam within 90 days. Now, if you're not taking an exam, then you don't even need the study guides, although I recommend you follow the study guide that keeps you on track. But you have a whole year to do it if you want. So the question really asks, when you start it, how long should it take? Typically, if you have a deadline to take an exam in a certain period of time, whether it's 60 days from when you start or 90 days from when you start, you're going to follow the study guides. And you can complete it in 60 days. You can complete it in 90 days if you follow the guides, right? But if you're not, and you're just going to go through it to answer the question, I typically tell people take about 4 months to casually go through the program and get all your competency reviews submitted and do, the practice exams are optional, but they're encouraged, that type of thing. So now we don't write the practice exams. The practice exams are purchased to go in the program. So you're getting that. Typically people would buy that and it would be an extra charge. We include them in it. So they're created and they're not perfect. There's a lot of great questions, but you think about it, there's over 800 questions in the question database. That's not including the competencies. So it's over 1,200 plus total. But just in the practice and final exams, that's about 800 questions. And they're designed like you would see on an exam. And they're all online. So it gives you that immersion of taking an exam online. But there's 5 or 6 questions in there that I'm a little iffy on. But again, I can't change them because we simply bought the module to be able to use with our students. So they're created. So what I do is I create a challenge to my students. I tell them, let me know if you can find the error, because if you can find it when you're doing the practice exam, that tells me you're learning. Okay. And you don't just accept something as the status quo. So I actually use that as a benefit. And I say, see if you can't find, right? See if you can't find the error. And usually the error is, it's not going to hurt you. You've heard me tell people before, good questions and bad questions are still good questions, because if you look up the question and the answer is what's wrong is what the issue is, not the question. It's usually the answer. So you test yourself. But I'm telling you, out of 800 questions, to only have about 5 or so that I'm a little iffy on, that's pretty darn good. I'm telling you, if you've never written exam questions before, that's pretty good. The other neat thing about it is you can try to find the error, and that's going to just help you even get better. But it's not going to change the validity of the question. The question is the question. It's just the answer. And usually what happens is it's because of a translation. In other words, going from one cycle to another, from 14 to 17 or 17 to 2020 code, they update the question, but something might have changed and they forgot to update the answer to reflect it. But again, I actually kind of like the issue of you having to find it. But again, they're rare, and most of them are usually in one exam or two. So, but there's a lot of bad questions out there. These are great questions. It's just the answer might be different because of some change from cycle to cycle. But that's your challenge, right? That's your challenge to see if you can find it. But again, there's only 5 of them out of 800 questions. So it's, most people don't find them. But it's the whole goal of a practice exam is to get you used to going through the code book, right? All right, so I kind of elaborated on that longer than I needed to. So to answer that question, I like it at least 60 days, 90 days, perfect. If you're casually going through it, it should take you about 4 months. But again, you have access for an entire year. So, Mr. Question Submitter, you can take as long as you want, up to a year, or you can follow the study plans to keep you kind of focused and on track, depending on when you have a test date. How about that? Okay. All right, let's look at the next question. All right, our next question was submitted. It says, so I'm doing a new building, which will get service from a nearby building. Okay. So this will be a 200 amp sub panel, which tells me it's not a service. So that's a feeder that's feeding from a nearby building. So should the footing rebar be the Ufer ground, or should be cement floor in the Ufer ground? Okay. And it says, should the floor rebar and the footing rebar be connected together? Thanks. Okay. And he says the building is 50 by 120. Okay. So the size of the building is irrelevant. So the question here is, since this is a detached structure, it's being fed from another building, so that's a feeder. And they're going to be having a panel in there, a remote distribution panel, which it calls a sub panel. So the question really is, one, do you have a Ufer ground, right? So understanding what a Ufer ground is extremely important, because you may or may not have a Ufer ground. Now, depending on how you describe it tells me you probably don't know, and there's a chance that whoever's designing this building is not being very clear on how they're designing it. For example, if I have a vapor barrier down underneath the footing, and again, nothing was meant, it did mention the footing rebar. Typically, the footing rebar is what we're going to be worrying about here, not so much the rebar that's out in the slab. Okay, we're more focused on the footing, and we'll look at the code and read that in a second. But the amount of footing rebar that's in contact with the earth, okay, 20 feet of rebar, in this case, since he's talking rebar, that cannot have a vapor barrier under it. If there was a vapor barrier, depending on where you are in the country, and I don't believe you say where you're at, then you might have a vapor barrier. And if that's the case, you do not have a Ufer ground. Okay. So remember now, the concrete is just part of it. The rebar, in conjunction with the concrete, creates a Ufer ground, which is named after Herb Ufer, which is the gentleman who did the testing in Arizona, and I can't remember where else. And that was done back in the 60s. And if you're in our grounding and bonding course, there's a great article on that that's free. It's in our course that you can read and learn all about Mr. Ufer, so I won't take you down that road today. But at the end of the day, it is probably pound for pound, cost-wise, from an electrician standpoint, the best grounding electrode system you can get. I mean, it's already there. Now, again, the caveat being that it is there, because if it's a vapor barrier underneath all of this footing and everything, so it's not in intimate contact with the earth, then you don't have a concrete encased electrode, or in this case, slang is Ufer ground. So that's important. So first you have to establish what you have. And it is not about connecting to the rebar that is under the cement floor. That is something that's going to be done by the building folks and building inspection if they want to tie those things together. Because you can have a slab that does not have rebar in it. You could have a slab that has fiberglass in it, mesh, or something else. But we're talking about the footer rebar, right? So that's going to take us to the code. So we want to go look at the code. I'll read it to you, and then you have to make a decision on what you actually have. Because if you don't have rebar in the footer in contact with the earth, then you're going to have to use a different electrode. Okay. So let's kind of look at the code, and we can dissect this for the question. All right. So hopefully you've got your code book. I'm going to be in the 2020 edition of the NEC. And again, I'm always in the latest published edition. So I get emails from people say, but that's not what it says in the 2017. I'm not in the 2017. I'm always going, all of my podcasts, all of my videos are always going to be from the latest published edition. What might be adopted in your state is irrelevant to my lesson. You're going to have to go back and read what's in your state. I am not going to do podcasts and videos for two different code cycles. Just not going to do it. All right, so if you go into Article 250, which deals with grounding and bonding, we're obviously talking about grounding electrodes here. And there's a couple of, we'll talk about them, kind of give you an understanding, because, answer your question, what you might be dealing with. Your mind is locked into a Ufer ground, which may or may not be present in your installation. So the different types of electrodes first, and that's 250.52a. And you'll have, when you go down the list, you'll have 8 different options here. The first option is A1, that is metal underground water pipe. Now, that only applies if it's in direct contact with the earth, 10 feet or more, okay? And it is in contact with the earth, and, okay, then you would have a metal underground water pipe. Remembering now, you have to supplement water pipes, okay? So we don't want to forget that, because that's a requirement that you're going to run into 250.53, and I believe that is D. And D2 is going to talk about supplementing a water pipe. Okay? And you can supplement it with any of the other ones that we're going to talk about here today, not just your Ufer that we're going to talk about. All right, so the water pipes, underground water pipe. Next is metal in-ground support structures. Doesn't sound like that's anything that you have here, because of the way you're talking about slab. This is typically I-beams that are going to be into the earth as a supporting component, or embedded in concrete into the earth as a supporting component. So if you have that, and you have that metal contact 10 feet or more in direct contact with the earth, okay, with or without concrete encasement, then you would have a metal in-ground support structure to be utilized as a grounding electrode. Doesn't sound like you have that. So the next one is concrete encased electrode, or as referred to in your question as a Ufer ground, named after Herb Ufer, who did all the testing for this thing. All right, so the neat thing about it, though, I'll say real first, is these first 3, the metal underground water pipe, the metal in-ground support structure, or the concrete encased electrode. The beautiful thing to the electrician is that these are things that typically we're not going to provide. They're either there or they're not, right? You either have a metal underground water pipe, because that was what's bringing the source of water to the building, or the construction of the building would be done so that you have metal in-ground support structures, driven into the ground or encased in concrete in the ground that's supporting the structure. Electrician has got nothing to do with that. If it's there, it's there. And then, of course, concrete encased electrodes are very much part of the construction, and that gets chosen at the design stage, right? Now, there is 2 options here. One being the use of bare copper conductor not smaller than 4 gauge, as long as it's 20 feet of it. So that could be something that's done by the electrician, but you got to get there at the right time, right? Because it tells you how to install it and where it needs to be. So again, it's a timing thing. So most of the time, what we see is a concrete encased electrode. All right, and it will turn up a piece of rebar at the panel location. Again, if it's all coordinated the way it needs to be. And again, we're talking about 1/2 inch rebar in diameter. So if you read 250.52a3, and we will, so that we can make sure that this individual that sent the question understands, do they have it? So the question he was asking about whether or not it's the rebar, whether or not it's the floor rebar, do they have to be tied together? As far as an electrician, the floor rebar is irrelevant to me. I'm not getting into that. Here's what the code says. It says, and I'm at 250.52a3, it says concrete encased electrode. It says a concrete encased electrode shall consist of at least 20 feet of either 1 or 2. Now, 2, we already said that'd be bare copper, not smaller than 4 gauge. But the 1 dealing with rebar is item number 1. And that says 1 or more bare or zinc galvanized or other electrically conductive coated steel reinforcing bars or rods of not less than a 1/2 inch in diameter, installed in one continuous 20-foot length, or if in multiple pieces connected together by usual steel wire ties, exothermic welding, or other effective means to create 20 feet or greater length. So this would mean that I could have, for example, 21-foot rebars connected together in order to create effectively 20 feet in length. Okay. So again, other people ask me questions about, well, what can I take 20 1-foot pieces, bundle them together and weld them all together? No, we're trying to create a length here, surface area. So again, people can argue semantics here. They can say, well, that's not what it's, whatever. But typically it's always been debated in people, even in code panel 5, is that we're talking about overlapping rebar if they were 1-foot pieces, welding them together. And people want to bring up the semantics. Well, the code says you could just take 20 1-foot pieces, weld them all together or whatever, and tie wire them all together and throw them into a ditch. Okay, no, it's not what you're going to see. Okay, because it talks about the way that they have to be done. And that's when we go to the portion after item 1 and 2. And here's what it says. It says, metallic components shall be encased by at least 2 inches of concrete and shall be located horizontally, okay, within that portion of the concrete foundation or footing that is in direct contact with the earth, or within vertical foundations or structures components of members that are in direct contact with the earth. Okay. Now it goes on to say multiple concrete encased electrodes are present at the building or structure. It shall be permissible to bond only one grounding electrode system. So in other words, you could have other systems like, let's say, vertically, you could have a vertical rebar constructed and surface area is obviously 20 feet, and you could have multiple, maybe like a pier construction. You don't have to jump around to all of them. As long as one of them is adequate and it meets all the rules and it's 20 feet in length, whether it's vertically or horizontally, the key here is that this is a length requirement, not just putting them together and bundling them. Okay. Now you can feel how you want to feel, that you can deal with your electrical inspector, but I can tell you, if they were to ask for an interpretation from somebody, they're going to say, this is all about length. It's not about the girth. Okay. No comments on that. All right. So, what's real important too is the statement that there's an informational note that reminds you: concrete installed with insulation, vapor barriers, films, or similar items separating the concrete from the earth is not considered to be in direct contact with the earth. That's real important because, like I said, vapor barriers and whatnot. But so to answer the question though, we were really talking about the footing, not the slab portion, the footing. And this is where all this has to take place. Okay. All right. So hopefully that answers that question. Now, of course, to round it out here, you have ground rings, you have rods and pipe electrodes, like, ground rods, things like that. But, people also forget that you can have pipe or conduit as long as it has a metric designator of not smaller than 3/4 trade size, right? And the outer surface is galvanized or otherwise metal coated for corrosion protection. I mean, you could have pipe. Sounds like, it's probably not what I'll do. It's easy to just drive rods, but that is your option there. Then it says other listed electrodes. So there could be other listed electrodes that have a listing for this. So there's like chemical type electrodes that get placed in the ground. They have a listing. They work. Then next one would be plate electrodes. Okay, so this is just basically like a copper plate, whatnot, or steel plates. And it's got to be not less than 2 feet of surface to the exterior soil. They are bare or electrically conductive coated iron or steel plates shall be at least 1/4 inch in thickness. Solid uncoated electrodes of non-ferrous metal shall be at least 0.06 inches in thickness. So you can deal with plates. Plates are very common in a lot of towers, as well as ground rings. Okay, and we talked to you, ground rings encircle the building or structure, and it literally encircles it. Okay, so it has a minimum length of 20 feet, but you have to encircle the building or structure. Okay, so, and it has to be at least 20 feet in that process. And then, of course, the last one would be 8. It says other local metal underground system or structures. Always check with your local AHJ because, you know, that means things like underground metal tanks might qualify. There's a lot of surface area there. Underground metal well casings. Just make sure you follow rules in terminating at 250.8. And all that is clarified with your AHJ. I don't see a lot of the local metal underground systems utilized, even though it's here. Most of the time it's a Ufer. Most of the time it's either the rods or whatnot, but you have other options here. All right. So one thing to remember though, what's not permitted to be used as electrodes, again, metal underground gas piping systems. So the gas piping systems, no, as an electrode. Don't use any aluminum for that application as an electrode. Okay. And of course the structure or structure reinforcing steel described in 680.26B1 and B2, that's the structural steel. That's the thing for the equipotential bonding and the perimeter around a swimming pool. Just because that's rebar and just because it's in concrete and it might be close to the surface, that is not to be used as an electrode. It might look like an electrode, it might, but it's not because it's not a footing. Okay, so don't do it. All right, so that kind of answers that question, I believe, on that again. So what you've got is a feeder to your 200 amp panel in your remote distribution. Once you get there, you're required to establish a grounding electrode system. At that point, you need to choose one of your options. If Ufer's or concrete encased electrode is present at the footer and it meets the definition in 250.52A3, if that's the case, then that's what you would use. Okay. And you wouldn't have to do anything else. You don't have to supplement it. You don't have to do anything else. And then of course, the next question is say, well, what size would my GEC grounding electrode conductor be from my panel, from that remote distribution panel over to the concrete encased electrode? If there, then you would go to 250.66. And since that sounds like that would be your sole electrode, okay, even though we don't have the term sole anymore in there, but that is your electrode, then you have the luxury of being able to use 250.66B, and that means that your grounding electrode conductor does not have to be larger than a 4 AWG copper. Can it be larger? Yes. Is it required to be? No. All right. But again, remember, as long as it connects from your from your feeder panel, hopefully I didn't say that again somewhere else, feeder panel over to the concrete encased electrode, and that's it, then it only has to be a 4 gauge. You don't need to supplement a concrete encased electrode. Okay. A lot of people do that. I don't know why. A lot of engineers do that. They'll put in rods and pipes and plates and rings, and I guess it's the effort to make sure they're below 25 ohms or whatnot. But that below 25 ohms issue or the allowance only applies to rods, pipes, and plate electrodes. So anyway, hopefully that answers that question in this episode. So let's see here. Let's see if we got one more to do. Maybe we can get it done here. Let's see. All right, this next question, again, if my effort was to not be lengthy, I'm probably not going to succeed here because this is a pretty long question. So this question came in and it asks, it says, I've been watching your videos and find them much more helpful than many others. Well, thank you. It says, I am now going through the Transformer series and maybe haven't gotten to it yet, but I'm trying to figure out when I can run Transformer secondary conductors more than 25 feet. Okay. It says, in the video series right now, you're going through the rules, but don't see anything more any more than in 240.21 or 240.92. He says, I guess I don't know that reference, in this 2017 edition. Says, if you have any advice, I would appreciate that. It says the engineer at our firm right now is saying that essentially, since it doesn't specify, just treat it like a feeder. But I would expect to have that note in 240.21 if that was the case. Okay. Also, I am an electrical designer, not an engineer, just trying to improve my skills and knowledge. Thank you, not just for this, but for the videos you have posted for free. All right, well, you're most welcome. Hopefully they teach you something. Again, for those that are wondering, we have a complete transformer series. Obviously, when I do videos, I can't cover every topic. We try to do our best, but there's so many ways and so deep that I could go. But go over to our YouTube channel, youtube.com/Master the NEC. Search Transformers in our collection. But I think you'll find them over in the playlists. And so if you look at the playlist, you'll see one on calculations. And I'm pretty sure that the Transformer series is under that. So go check it out. You may like it. You may not. Okay. Feel free to thumbs up or thumbs down. I really don't care because I don't share that info with anybody anyway, because you have trolls everywhere. But at the end of the day, let's kind of look at this question. So first of all, when we're dealing, the question is, what does the code say when it comes to the situation of more than 25 feet? Now, let's clarify here, because 240.21, you have feeder taps, and that is under B. And in C, you've got secondary conductors, which replicate like we're tapping. However, it's basically being derived from the secondary of a transformer. So we have to get our code books and we have to go look at it, because the question is, again, what about if it's more than 25 feet? Now, you have to remember that you have specific rules that are given here. And in our case, we're looking at this secondary conductor rules and 240.21c. And here's what it says, and we'll kind of dissect the question. Yeah, make sure my mic is here. Okay, it says a transformer's secondary conductors, it says a set of conductors feeding a single load or each set of conductors feeding separate loads. Oh, and if you don't know where I'm at, I am at 240.21c, where it says transformers secondary conductors. Okay. So it says a set of conductors feeding a single load or each set of conductors feeding separate loads, because yes, you could do multiple loads from a transformer if it's sized properly, shall be permitted to be connected to the transformer secondary without overcurrent protection at the secondary, as specified in 240.21c1 through c6. Now, I'll read the next one because it's real important, but I want to stop right here for the engineer and the engineer designer and everything. Look, these rules are about extending secondary conductors without overcurrent protection at the secondary origin point. If you take those secondaries and you hit an overcurrent device, then on the secondary side, well, on the load side of that disconnect, you can go any length you want. Okay, they're protected. So this rule, 240.21c 1, 2, 3, 4, 5, and 6, they're dealing with how far you can go in this installation where you do not have overcurrent protection at the source, which is the secondary. So that's important, and that gets lost a lot. So these rules are only under this condition. If I come from that secondary and I hit a panel, then the feeders that come out of that panel, they can go as long as you want. Of course, voltage drop being considered, again, not a requirement in the code, but it's a recommendation. Other than for fire pumps and sensitive electronic equipment, other than that, voltage drop is a recommendation. You can go as long as you want. It's protected. So this is a situation where you're going to be limited based on the fact that you're coming from a secondary of a transformer and you're not putting overcurrent protection at that source point. Okay. That's important. Very important. Because if that is the case and you're coming off the secondary of the transformer, you do have to follow the rules in C1, 2, 3, 4, 5, and 6. You don't necessarily just say treat it like a feeder and that's it. Okay? So important. Very important to understand that. So paraphrasing each one of these real quick, you have a C1, which is protection, primary overcurrent protection. So that's when you have protection on the primary and it's going to be protecting the secondary. Okay. That is under very specific allowances, right, to follow this rule. All right. So you could do this and yes, your secondary conductors would be protected and there's theoretically no length limit on them. There's no rules, 10-foot rules, 25-foot rules, because they're protected by the primary overcurrent protection for that transformer. If that's the case, and again, it's only going to apply to certain, 2-wire single voltage secondaries or a 3-phase, three-phase delta connected transformer having a 3-wire single phase secondary are permitted to be protected by the overcurrent protection on the primary. If it's single phase and it's other than 2-wire or multi-phase, like a 3-phase, other than a delta, then the secondary conductors are not considered protected by that primary, and you got to follow these rules. So C1 is very specific. Make sure you meet that rule in order to do that. So it kind of sounds like that's what he's telling you. Treat it like a feeder, and you can just follow all the feeder rules. Well, not unless it's a specific type of voltage and it meets the requirements of C1. So we're going to assume that's not the case, and we're going to throw that off the table. All right, now C2 is a 10-foot limitation. So those secondary conductors from the transformer are not over 10 feet. Okay. And the C3 is industrial installation secondary conductors not over 25 feet. Okay. And your question's about over 25 feet. So, I mean, these rules, so even industrial at no overcurrent protection at the source, secondary of the transformer, will let you in an industrial installation not to exceed 25 feet. Then you could follow all the rules there. There's 4 different conditions that you'd have to follow. If you meet all those, then we'll let you do that. And again, this is all about not having overcurrent protection at the source. And that is at the secondary side of the transformer. The next one would be outsized secondary conductors. Now, this one is important because this one does not have a length limitation, provided that the secondary conductors are what? Outside of the building or structure, except at the point of termination. Obviously, you got to get into the building. So the moment that they come into the building, then you think of all those rules with services outside or nearest point of entry for the, application of the disconnecting means. So if you follow those kind of concepts, then I could be outside. If the transformer's outside, secondary conductor's outside, I can run them forever before I came into the building. Then you got to follow the outside disconnecting means or nearest point of entry. In understanding that the rules considering outside of the building in 230.6, which is again for services, is still going to be applied here. Because if it's outside of the building, it's a certain depth or encasement, then it's considered, in theory, still outside of a building. And that happens all the time when you have to go underneath the building to get from, to wherever the gear may be. All right. So, but this is unlimited length as long as you can meet the rules. Now, I'm going to take it in your question. It's not outside. So you say, well, I can't use C4 because it's not outside. Okay. So the next one we're dealing with would be C5. Now, C5 says secondary conductors from a feeder tap transformer. Okay, so you have a feeder and you're tapping that feeder to supply a transformer. In this case, the secondary conductors from the feeder tapped transformer means what's coming from the actual transformer based on the allowance of 240.21b3, which was a feeder tap. So you tapped a feeder to supply a transformer. Well, what this is saying is transformer secondary conductors installed in accordance with 240.21b3 shall be permitted to have overcurrent protection as specified in that section. So when you're dealing with this application, follow the rules in 240.21b3 as if it was a feeder, because the feeder tap rule there is basically tapping a feeder in order to be able to supply a transformer. So you follow all the rules there and then follow the portions of 240.21b3 about those secondary conductors. And it gives you the rules in there how to do that in 240.21b3. Okay, so we won't rehash that one. But just so you know, B3 has got B3.2, that's 240.21b3. There's an item 2 that you got to be aware of. There's an item 5 you got to be aware of. So basically, if you're going to be dealing with the secondary conductors off of a transformer that's tapped to a feeder, then you got to go back and look at these rules as well if you're dealing with that application. All right, and so the next one and the last one we'll deal with is C6. And that says secondary conductors not over 25 feet. So in this here, it says where the length of secondary conductors does not exceed 25 feet and complies with all of the following. So you have 3 conditions that you have to meet. Now, to answer the individual's question, there is a length limitation that the only way around this is if it's outside of the building, then it could be over 25 feet, clearly. We discussed that. It's very clear in C4. But if you were to go from that secondary and hit a disconnect that complies with the 10-foot rule or the 25-foot rule, then the conductors that leave that, let's say feeders, then they could go more than 25 feet. So it sounds like in your question, it doesn't say anything about being outdoors. And so the whole premise here is that you have no overcurrent protection at the secondary connection of the transformer. If that's the case, then you have to limit the length. Now, why does it allow it to go longer with it outside? Because it's less of a hazard outside of it acting like a fuse or whatever. It's outside of the building. But again, it must terminate once it enters the building, immediately terminate into an overcurrent device. So at the end of the day, I think that the engineer is probably giving you poor information. You don't treat it like a feeder. It is secondary conductors. It has these rules. Now, again, if they want to immediately go, the way to get around this is to immediately come out of the transformer secondary and hit a panel. Say you're following the 10-foot rule here. Hit a panel, and then from there, continue on to whatever load you're trying to go to, and then the length is going to be irrelevant at that point, right? As long as your overcurrent's protected properly for the feeder that's downstream, then you're perfectly fine. And that would be my recommendation in order to comply with what you're trying to do here, right? I think people look for, how can I go further than 25 feet? That is not possible on the secondary conductor rules of 240.21c unless it's outside of the building. If it's inside of the building and you're going to have no overcurrent protection at the connection of the secondary of the transformer, then you're going to be limited on the length that you can go. And the only way around that is to follow maybe the 10-foot rule and maybe put a panel a couple feet away, and then you can take out of there, then you can continue on and go as long as you want. Again, hoping you observe the recommendations of voltage drop, but that's up to you. It's up to the designer, but those are my recommendations for that type of application. So anyway, I hope that you got something out of the episode or got something out of today's, because again, that's what Ask Paul is all about, that you can submit your questions and I will elaborate on them and hopefully you learn something from them. So again, it's a way for me to kind of just answer questions that come in. If you want to send questions and get them answered by email, as well as potentially make it to a podcast, then send your questions in, please, by all means. Just go to paulabernathy.com. At paulabernathy.com, there's a form there. You simply fill in your question and it comes straight to me. It goes straight into my portal program, and then I can easily access and answer those questions for you. Again, anything about the National Electrical Code, feel free to ask. If I know, I'll tell you. If I don't, I'll tell you I don't know. So until next time, folks, stay safe. God bless.